Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin our 63rd CoCoRaHS Weather Talk webinar. Wow, 63 of them so far. Well, hey, thank you for joining us today. I'm your host, meteorologist Henry Regis, and running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in what looks like, out my window, partly cloudy Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we are recording today's talk, and it will be available later this week on our website for future viewing. All of our Weather Talk webinars are sponsored by generous donations from listeners just like you. Well, today we're going to talk about the National Weather Service and their ongoing effort to build a weather-ready nation. We're very fortunate to have with us today Paul Schlatter, the Science and Operations Officer with the National Weather Service Forecast Office in Boulder, Colorado. A little background on Paul. He was born and raised in Boulder, where he knew he wanted to be a meteorologist by age 8, and we'll ask him about that shortly. Paul was educated at Westmont College in Santa Barbara, California, went on to grad school at the University of Oklahoma. He started his weather service career in 2003 in Norman, Oklahoma at the Warning Decision Training Branch as an expert in radar analysis and warnings for severe storms. From there, he went on to D.C. and spent 5 years at the National Weather Service headquarters, working with the director of the Weather Service and the administrator of NOAA in various positions. Most recently, in 2016, as the acting chief of staff for the Weather Service. Then in 2016, in August of that year, he fulfilled one of his lifelong dreams to work for the Boulder Forecast Office. He's there now and plans to stay there for a long time. One thing you may not know about Paul, he's the incoming president of the National Weather Association starting on January 1st here in 2019, right around the corner. Paul tells us that also a little bit about family background. He has a very a very smart wife who works at a sister agency there in Boulder, NIST, the National Institute of Standards and Technology. He has 2 kids, ages 12 and 10. In his spare time, he likes to ski, hike, coach, and watch his kids play sports, and of course, spend time with his family. Oh, and one last fact, I like this one. His Twitter handle is @DualPaul. Yeah, you get that. Play on words regarding his expertise in dual pole radar. You got to love that. Well, welcome, Paul. It's great having you, an old friend and longtime CoCoRaHS observer, with us today. 8 years old. I'm sure there's a story there. Tell us a little bit more about how you wanted to become a meteorologist at that age.
Yeah, I was one of the fortunate few kids out there that had a dad for a meteorologist, Dr. Tom Schlatter. And he's actually given a CoCoRaHS webinar in the past. He's now retired, but gosh, I had at my, my formative years an expert in the field just kind of guiding me and showing me the way on all things related to meteorology. And so my interest started really young. I mean, I was when my dad would go on vacations or business trips, he takes meticulous weather records, especially for CoCoRaHS, but this is way before CoCoRaHS. And so I would take observations for him. And I went so far as to record myself talking about a rainstorm for him as it was going on. So kind of reporting the weather back then. And so I knew that was what I wanted to do. And then I'd say a lot of meteorologists that you out there have met, this is probably the case for most of those. I had a single storm that kind of changed my life in that once that storm occurred, I knew the only job I wanted to do was meteorology and warning and forecasting those types of storms. For me, it was a hailstorm July 11th, 1990 in the Boulder, and then it moved on to Denver, but it hit Boulder first. And it was, it was a nice warm summer day, and I was out playing with 3 friends in an open field in East Boulder. And I saw this supercell coming right at me from the north. I'd never seen clouds move that way because they were slowly rotating. I'd never seen a shelf cloud quite that way before. And everything was it was green, and it was constant lightning coming right at us. And I knew it was going to be bad. And so I started to say, I think we should start to take shelter as we were playing out in the open field. But no sooner had I said something along those lines that the first type of precipitation to hit us was about a 1-inch hailstone. I mean, it started hailing out of this storm almost immediately.
Ouch.
So we
Wow.
started a run. We had probably, we probably had to run for 2 minutes, dead sprint, to get to the house where my friend was living at the time. And throughout that, we were getting hit by 1 to 1.25 inch hail. And so yeah, it definitely hurt when that hit our shoulders, our arms, a couple grazed our heads. But thankfully we got to shelter before the real big stuff hit. And anyone on the call that remembers that storm, at the time in 1990, it was the costliest hailstorm in U.S. history because it went from Boulder and then to northern Denver, and then went on the west side of Denver, impacting an amusement park and injuring a lot of people on the rides because they hadn't gotten the people off those rides in time, even though they had time to prepare. Anyway, that was the storm that did it. After that, I said, I wanted to warn for these storms because I'd never seen anything like it, and it just fascinated me.
Wow, that is quite a story. Yeah, many of us have had experiences in childhood that brought us into meteorology. I remember I was 8 years old as well when lightning hit my house, and I'm sure many of you on the call can remember stuff similar to this that got you interested in weather. Well, thanks, Paul. I'm going to hand over the reins to you, and we look forward to your presentation. And we'll take questions after Paul's presentation is finished.
Okay, thanks, Henry. And can everyone see my screen now? Does it look good?
Looks great.
Okay. So, and thanks for having me. I was honored to do this for Henry and for the CoCoRaHS program, because I've been since it came to the state of Oklahoma, when I used to be living there, I wanted to become an observer. I was one of the first ones to sign up in Cleveland County, which is Norman. Then we moved to Maryland, and as soon as we purchased a house there, which was a few months, I got the CoCoRaHS website account up and running there. And then we moved to Colorado just a couple of years ago, and now I'm in Jefferson County in northwest Denver there, and got my gauge up and running and ready to go as quickly as I could. So I love the program. Honored to be talking to you all out there. And as a Weather Service employee, I thank all of you for sending in your reports, because we do use those. In fact, over the weekend, we had a snow event, and I was hoping there were more CoCoRaHS observers in the area, because we needed a few more reports out in some really data sparse areas of our foothills and mountains, just to get more reports to fill out a storm total snow graphic. So we do use your reports, and thank you so much for the reports. They're unbelievably helpful. So what am I talking about today? What is a weather ready nation? So I'll discuss what that is and why we need it, how the Weather Service is building a weather ready nation. And then I'm going to go into a local example just to kind of illustrate what that might look like at the local level. And then I'm also going to talk about nationally a national program to improve how we communicate watches and warnings. And so that's the final thing I'll cover today. So as a nation, are we weather ready? As you can see on this graphic from 2018, this shows all the billion-dollar weather and climate disasters that have occurred so far in 2018. Hurricane Michael, it's not even a question. It will be number 12. It did just take a little bit of time to certify that it's going to be a billion-dollar disaster, but that clearly will be the 12th of the year. You can see out in my neck of the woods, we had a really bad series of hailstorms on the 18th and 19th that exceeded $1 billion. But there's a lot of high impact weather that can cause billion-dollar disasters. And it's not so much necessarily that the weather itself is getting worse in any shape, though that is part of it. But I think the biggest reason that these things are happening is the vulnerability of the population. And I'll get to that a little bit more on this slide. We as a nation are more vulnerable to these types of weather and climate disasters, because notice where everybody's moving from less populated parts of the country to more populated parts of the country. And especially notice along the coastlines where hurricanes hit, where floods occur, and those types of things. That's where those green colors are. So people are moving out of more rural areas to more urban areas and more coastal areas. And that puts, as a nation, the population at a little bit more risk to things like hurricanes and other natural disasters like tornadoes. There's a pretty good tornado alley. I know the plains people are moving out of the plains, but the Southeast has a pretty good tornado, the Dixie Tornado Alley as well. So vulnerability is increasing across the U.S. As these weather disasters keep occurring. And so we need to really focus on how to prepare for those types of events because we are more vulnerable. Here's the trends in $1 billion disasters. That was one of the questions that when you registered, you answered. And over the last 5 years, about how many billion-dollar disasters are there? Here's the last 5 years. It's roughly about 12. We're averaging about $12 billion disasters over the last 5 years. But notice since 1980, we never even had $12 billion disasters. Up until 2008 was the first year we got even up to $11 billion disasters. Katrina sticks out here as an event that really caused unbelievable amounts of damage. But in the end, over the year, there weren't as many billion-dollar disasters that year. But you can see the trends going up as we become more vulnerable to these types of events. Hurricane Sandy is shown here with a lot of the damage here in 2017. Oh no, Sandy was earlier. Sorry about that. But yeah, lots of damage and increasing trends in billion-dollar disasters, averaging about 12 per year now. So what does a weather-ready nation look like? Well, here's the definition of the Weather Service that we came up with. And that's where a society is prepared for and responds to weather and water events, and that those communities are ready, responsive, and resilient, using alliteration there to highlight what we hope a weather-ready nation looks like. And so what does that require out of the National Weather Service and out of the communities we serve? It requires this thing that we call impact-based decision support services. And I'm going to explain what that is in just a second. But I think the key point to make regarding the value of a forecast and how forecasts are used is that an absolutely perfect forecast is useless, or you could even say worthless, if decision makers don't make smart decisions based on that information provided. In other words, I work in the Boulder forecast office. We could have provided the perfect tornado warning 20 minutes away for downtown Denver. We knew we could tell exactly where it was going and how strong it would be. Let's say we could do that. Well, if all the people in the path of that tornado ignored it or didn't do anything with that information, what good was that forecast? Damage would still occur. People could probably still die because they didn't take protective actions. So there's an intrinsic value to the information that the National Weather Service provides. And the only way it earns value or achieves that value, achieves a benefit, is if smart decisions are made based on the information provided. So that is our task as the National Weather Service, to not just issuing accurate forecasts, but making sure that the people that receive that information make the right decisions. That's what IDSS, or Impact-Based Decision Support Services, aims to do. So what are they? It's a combination of generating those forecasts and warnings, and then connecting that information with the partners in their decision-making process. That is what IDSS is. So just an example of that, some of the IDSS that we do is, let's say a big winter storm is coming. We know it's coming maybe 48 hours ahead of time. So what IDSS is we will have conference calls with all of the emergency managers and other city officials that make decisions on plowing roads, on schools, on all the different things that have to be done, on opening warming shelters if it's really cold too. We'll have calls with those people days in advance just to give them a heads up that it's coming, and we'll communicate in a language that makes sense to them. Speak in their language. We can't be weather geeks on those calls. We really have to be careful about how we're providing the information and making sure that they can make actions based on that information. It's not just conference calls. We'll provide them slide decks with graphics that show all the impacts that are coming. We take their phone calls afterwards if they have questions about it, and they trust us. And there's a reason why they trust us, and we'll get to that in just a little bit. But it's all those types of things are what we mean by what is IDSS. So the process of delivering it, I mentioned you really do need to have accurate forecasts, because let's say we provide bad information, and then bad decisions are made based on that. There's a level of trust that gets lost if you're constantly issuing poor forecasts. On the other hand, if you're constantly nailing the forecast, our partners will trust us and say, well, last time they said it was going to snow a foot and it did. They're saying a foot this time. I think we're really going to need to pay attention to this one. So accurate forecasts are the foundation for IDSS. The second piece is developing relationships and understanding their needs. You know, former FEMA administrator Craig Fugate once famously said that the time to be exchanging business cards is not in the middle of a disaster, because there's so much else going on, and you don't want to be meeting someone for the first time that you need to trust and provide information to if it's in the middle of a disaster. So for months, years leading up to an event, prior to an event, we meet regularly with our core partners in emergency management, broadcast media. We're making sure that those relationships are developed and that we understand how to deliver the information to them. So whether that's practicing with exercises well ahead of an event, and then during an event, if requested, we will send a forecaster to be in the emergency operations center and providing information directly to them. So that's another thing we do that's pure IDSS. And then finally, because of all the pre-work that we do leading up to an event, they trust us, and our main focus is on customer service, making sure they know how to make those decisions based on our information. So a local example of the importance of IDSS, and I want to be clear here that this isn't necessarily a new concept in the National Weather Service. I think it's fair to say we've probably been doing some level of IDSS for the past 20 years. The renewed focus on it is ensuring that all offices, there's 122 of them across the country, all offices have access to the same tools to do this, have knowledge of the right methods to do it, and just kind of, in some level, standardizing the level of support that we provide across the country. That's the renewed focus on IDSS towards building a weather-ready nation. So a local example, back in 1976, the Front Range of Colorado had a devastating flash flood event. And back then we just had, communication in general wasn't that great. We just had a traditional suite of products and services. We had relationships with emergency management, but it was nowhere near the level it was today. And I think all of those types of things, in addition to a tremendous rainstorm in a very flash flood prone canyon, led to 144 deaths. And the 8-inch rainfall contour, in other words, everywhere inside this red oval, roughly about 8 inches or more rain fell. Contrast that to the 2013 floods and look at the 8-inch rainfall contour there, how big it was. Covered an enormous area over a several-day period, with several areas, including my dad's CoCoRaHS site, getting about 18 inches of rain in a 5-day period down in this area of Boulder County. So the point here is that in 2015, despite having that much more rain fall over a gigantic area, because of science improvements, our forecastability is dramatically better since 1976. We have modern communication systems now, including cell phones and all type of mobile technology, including Wi-Fi. But we also feel that a big reason why the 2013 floods weren't as tragic was because of the relationships we built with Boulder County Emergency Management, with Larimer County Emergency Management, with the state at the state level. That was years of partnering and doing drills and interacting with them and earning their trust that led to much better decisions made and overall just a better response to those floods in 2013 that were so devastating, which only resulted in, still tragic, but 9 deaths in 5 days. So I think we're seeing the fruits of that transition in the National Weather Service to IDSS on just better results, better decision making. So shifting gears just a little bit with IDSS. So IDSS is mainly the communication form and partnership. But I think a major foundation of that is accurate numerical weather prediction. Because as I mentioned before, you can't have a perfect forecast really doesn't have any value. You've got to communicate those impacts. But it's also true that without accurate weather prediction, we lose their trust. People start to discount our forecast because they're wrong all the time. So that's why we need accurate weather prediction. So using an example of a hurricane, because I know a lot of the listeners out there are in hurricane-prone areas. Let's take a look at how far forecasting hurricanes has improved over the past 25 years. Starting with Hurricane Andrew in 1992, there was a policy out there that using global models for the official forecast, the Weather Service wasn't doing that because they just weren't very accurate. The American global model back then, it's now called the Global Forecast Model, or GFS. It did produce a cyclone, a very weak one, low pressure area, and that was considered a success in 1992, when it just has a minimal low pressure system depicted for a hurricane. That was a success in 1992. And obviously that policy has been changed dramatically since then. So moving forward 13 years to Katrina, what was the state of the predictive science? Back then, we were able to predict the location pretty well, 5 days in advance for a landfalling hurricane. We started doing the cone of uncertainty, just to kind of show where that track, the center of the storm might be, though impacts are well outside of the track. But we did start issuing those types of forecasts 5 days out. Intensity was still an issue, though. Getting how strong is the hurricane going to be at landfall? How strong might it intensify or de-intensify or weaken? That was a challenge back then. Fast forward to 2017 in Hurricane Irma, which was a particularly challenging storm because it could have hit the west coast of Florida, the east coast of Florida. There was a lot of real estate and people in the way of that one, depending on just minor changes in its track. But our numerical weather prediction has gotten good enough such that we are able to do a decent job roughly 10 days out with a hurricane, where it might go, how strong it might be. And we were able to do that with Irma as it came off the coast of Africa. So we were watching this storm for 10, 12 days out. We still have, if there's an issue in predicting hurricanes, it's still with intensity. Those are still a challenge now. But amazing in just 25 years how far we've come from just barely being able to depict a hurricane with numerical weather prediction to being able to track it with a pretty good degree of accuracy 10 days out. So in terms of weather prediction, that's where we are. But where have we come from in terms of impact-based decision support services? Again, using the same three examples. So in 1992, just the Hurricane Center, the National Hurricane Center, which is in the National Weather Service, was connected to national and state emergency managers. Not much local presence at that time, or not a whole lot of coordinated local connections with the local offices and the local emergency managers, which meant that FEMA and the National Recovery Assets were not pre-positioned and very slow to react to that natural disaster. And it actually took 4 days after landfall before the impacts were recognized, and then they were able to rise up to meet those challenges. So 13 years later with Katrina, everything was much better connected, but mainly with the national and state emergency management at that level. There was not consistent and variable connectivity with the local EM community. It varied by state, of course. There was national pre-coordination of response. That was actually problematic in some states. And then in general, the recovery and supplies were overwhelmed because, again, just understanding the magnitude and preparing ahead of time wasn't quite there. So in 2017, we had a huge year for landfalling hurricanes in the U.S. with Harvey, Irma, and Maria. And then for those events, from top to bottom, every office, every county, we were all very well integrated with the emergency operation response days in advance of these landfalling hurricanes at every government level. So it was a ready, set, go mentality with the EM community. That was starting a week in advance for most of these storms. And so we were just so much better prepared, so much better connected with our core partners in emergency management. And we were consistently messaging these things for all those decisions. So what about Florence this year? I don't have Michael, but I do have Florence to show a video of how we forecast another tricky landfalling hurricane. Because as you notice, we were forecasting it would make a left turn, which puts it directly into land, and we were predicting that several days out. So let me animate this. But in general, if you notice, the landfall spot was consistently, I'll play that again, was consistently that Wilmington, North Carolina area. I'll do it one more time because I think it's pretty impressive. days in advance, we were that accurate, getting the track right, despite how tricky that forecast was for Florence. So I think we've come a really long way in terms of prediction. Let's look at rainfall prediction for Florence, which is also a really big deal. On the left is the 5-day forecast that shows rainfall amounts, getting up to about 20 inches, and then, a wide area of 5 to 7 inches across the Carolinas. And then this is what actually fell. So that's a pretty good depiction of rainfall. So we're getting pretty good at 5-day forecasts of rainfall as well. And what decisions were made based on that information? Here's an example from the maritime community of wise decisions that were made based on a forecast days to a week in advance. So what you see here are ship or cargo locations spread across the Atlantic Ocean, and you notice inside where the hurricane was forecast to be, there is nothing there, which is exactly what you want. You don't want ships going anywhere near the center of a hurricane. And then, so they were anchored properly outside of the heaviest duty, where the worst waves and the worst impacts from the hurricane would be. Most of them were anchored well outside that area. And the ones that were anchored inside where the landfall was going to be, no one was in the water, and they were at a safe anchor spot preparing for that hurricane. So really good decisions made based on accurate forecast information. This here in a nutshell is what IDSS is and what the Weather Service is trying to do to build a weather-ready nation. So going to a local example, I wanted to provide, in every office that gets snow will have these types of products that I'm going to show you. So, and it'll have a website for your local office where to find this information. But just specific to Colorado, I wanted to show that snowfall forecasting is a major challenge because of our terrain. And we as an office, and all the offices that have complex terrain like ours do, need to do a good job in this IDSS framework of communicating the uncertainty of the snowfall to our partners. Why is it so challenging? Well, if some of you have been to Colorado before, it's because of our mountains. But if you don't live in the area, it's also a big challenge because of terrain gradients north and south of the Denver metro area. And really at the I-25 corridor from Fort Collins to Denver and then to Castle Rock, roughly 3.8 million people live in this red rectangle. And so to the west, we have those gorgeous mountains that I'm looking out my window at right now. That's a huge 6,500 foot gradient from the adjacent plains that rises really quickly straight to the west. But to the north, there's also a terrain feature called the Cheyenne Ridge that goes from the South Platte Valley up to Cheyenne, and that's about 1,800 feet. To the south of Denver, actually starting on the south side of the metro area, is the Palmer Divide terrain feature, which rises 2,000 feet above the general elevation of Denver. So we're surrounded by features on all sides that make snowfall forecasting very tricky. This is a famous graphic that we've had going in our office for 15 years. It just kind of shows, as a lot of you may know, upslope flow at low levels is a favorable condition to generate snowfall, especially in terrain. And so at various places across our area, depending on the wind direction, that is an upslope direction. So understanding where the moisture is, understanding where the low level flow is that would be favorable for upslope flow is always a constant challenge across our area. Because you can see various parts of the metro area, if you get northerly flow, that's really going to hammer the south side of the metro to Castle Rock. But easterly flow doesn't get them as much. Easterly flow will get the west suburbs. It'll get Boulder really good. It'll get a lot of Metro Denver, the northern part of Metro Denver, really well. And whereas up where Henry and Noah live in Fort Collins, they really like southeast, southeast, or southeast flow up in the Fort Collins area to get good snows. So always a challenge out in Colorado. And so some of the things that we've done to help improve that, this is a national initiative called Probabilistic Snow Forecasts. And the purpose of those is to communicate the uncertainty in that forecast for a range of possible snowfall totals to those decision makers. So again, this is a IDSS example. So the scenario here is, let's say as a forecaster in the National Weather Service or broadcast media, that our official forecast has 10 to 16 inches of snow. But we know, based on model guidance that we've been looking at, that there could be up to 2 to 3 feet of snow from that same storm. But the problem in the past was that we pretty much were restricted to giving one value. We were restricted to giving one value, the most likely forecast, 10 to 16 inches. So the ability to communicate that, oh, there is a decent chance of getting a lot more snow, which could totally shut down the city. We didn't have a good way to communicate that until this new initiative here, Probabilistic Snow. So how does it work? So basically, each local office generates that storm total snow, and that becomes the expected snowfall. And then we apply what we call an ensemble solution, which I'll explain in a second, that generates the how much snow could potentially fall on the high end, and how much snow could fall on the really low end. What's the minimum amount of snowfall expected? What's the maximum amount of snowfall expected? And that's where those percentiles come in. And I'll show graphics of that. So what is an ensemble solution? What makes this such a special case? Well, this may look a little confusing, but once you figure out what you're looking at, it'll start to make sense. Snowfall amounts, where's my cursor? Here we go. Snowfall amounts in inches are on the left. So there's 0, and then up to a foot of snow is right around here, and then up to 18 inches. On the x-axis is in time. So the current time, this is an example from a couple days ago. The current time is right here, and then going out in the forecast area in time. So 1 day out, 24 hours from the current time is here. 2 days out is over here. What you're looking at here there's 46 different forecasts that make up this line. So it shows that in a little bit, most of the forecast models are showing just a little bit of snowfall, and then maybe a little bit more just over a day out. So snow is increasing with time there. Each one of those lines is a different forecast model with its own unique solution. And what we found as Weather Service forecasters is, when you combine or look at the attributes of each of those individual forecasts, so when you combine 45 different forecasts, that's what an ensemble is. We can extract useful information about how likely or how possible it is to have an extreme amount of snowfall versus is it going to be just more a moderate amount of snowfall. And one of the things we use is the mean forecast, which is the mean of all 45 ensemble models put together. Is it's about 2.5 inches for that area. But where we get the uncertainty information is some of these models, as you can see, they get kind of crazy a little bit. This model in particular is notorious for being way too high. But occasionally we might get surprised by a really big snowfall amount. And in theory, an ensemble solution will be able to depict where those high amounts, or if those high amounts are even possible. And so it gives us a lot of information on how likely or how possible. So we think there's going to be 2.5 inches, but there are several models that have up to 5 inches. So 5 inches is not out of the realm of possibility. And so we are now able to communicate that uncertainty information about just how bad it could possibly be. And this is what it looks like. So the expected snowfall amount is over here. That's our official forecast. That's when we say, we're expecting this much snow to fall. So that's the official forecast. But there's also these products where there's a 1 in 10 chance of higher snowfall, and that was the the higher end amounts. Those were the members that had a lot more snowfall. So in this particular case, it's going to be quite a bit higher for most of the state. On the other hand, what's the 9 and on the lower end of the amounts? When you look at 90% of the models, 90% of those models have at least this much snowfall, is what that's saying. So that's the low end amount. And every forecast office that's getting snow or could potentially have snow will have these types of products for your local area. So I think it's kind of neat for users out there to see, kind of get in the mind of the Weather Service forecaster. He or she is expecting this much snow, but oh my gosh, they're saying there's a possibility of getting that much snow. It's a very powerful thing. We also generate these probability of exceeding a certain threshold, which a lot of our partners have found very useful, in all these different values. So let's say you're in Denver and you're curious, maybe 2 inches is a pretty big deal for you. The chance of it in Denver of exceeding 2 inches for this particular event is 33%. We can put a value on that, and then you can see as we get up to 18 inches for this particular event, there was very little coverage, very low percentage of anything exceeding 18 inches, even in the snowiest parts of the Rockies there. Just showing that there's 46 individual forecasts that go into this, and then it's sent to the forecast offices across the U.S. and then we make a local snow forecast in all of our areas. The website, just for your information, it's weather.gov/ the office that serves you, and then / winter. And I can show you what ours looks like now. Not going to have a whole lot of snow in there. You can see the expected snowfall for the next 3 days. Not looking so good for ski areas or anyone really. There's a little bit on the eastern plains, but that's what this website looks like. We've got the high end amount, the low end amount, and the expected amount. And if you really want to get detailed for your particular area, we also have tables for select locations across the local area, and it's possible that where you live has its own little entry here, and you can really dig into the stats if you want to on what snow might be expected to fall. So a real world example of how the National Weather Service uses this information to communicate to core partners. We use the high end amount and the expected amount in all of our briefings to the Colorado Department of Transportation, which is pretty much our most, we have really important customers all over the place, but CDOT's right, near the top of that list. And so what we do is we provide state level graphics to them, what's expected and how much could possibly fall if all the conditions fall into place for this particular event. We assign a confidence level, and then we send them kind of a brief overview of what to expect in general for the state of Colorado. The Pueblo and the Grand Junction office, we all tag team on this. We talk about which commutes will be affected for this particular event. In this example, it was mainly a mountain event, so we're covering which mountain passes would be significantly impacted. And we also provide information on winds, because even if it's not snowing that heavy, when you throw 50, 60 mile per hour winds in there, the roads are going to get really bad in a hurry, and visibility is going to be really bad. 2 things very important for CDOT to know about. So what we do is then we take that snowfall product and zoom into where CDOT has their maintenance crews working. In this, there's well over 20 across the state of Colorado. I just picked the Vail Pass to Georgetown area because that's a heavily traveled stretch of I-70 where there's 10 to 15 ski areas. If you're driving across Colorado, you pretty much have to drive through this stretch. So it's a very heavily traveled, high impact zone. And so we give them a beginning time and end time, the general rate of snow that we expect, and then any additional details. And then each zone has its own graphic for snowfall and wind gusts. And CDOT has found these extremely useful. We end up briefing them prior to a snow event, sometimes 2 days out, but certainly the 24 hours out, we'll brief them on the phone and provide these slides so that they have the information they need to hopefully make decisions on how many plows to put out there, how much additional staff to call out, those types of decisions, which are critical to keeping roads clear for travelers. And so that's how we're using this information to build a weather ready nation using IDSS. So switching gears to something that also impacts everyone out there listening, and that's how we communicate watches, warnings, and advisories. And we have a new, it's new-ish. We've been looking at this thing for many years, but the formal project's been going on for 2 to 3 years. And that's how to simplify all of our hazards. And so I'm going to show you something that I found really funny about winter weather watches and warnings from a Letterman episode many years ago. So I'm going to turn up my speaker so you can hear it. Stand by. Let's try this now. And I'm going to hit play.
The National Weather Service, they're not kidding around about the snow. They've released this alert. Take a look. A major snowstorm is now a certainty for the northeastern U.S. The National Weather Service has issued a winter storm watch, which will soon be upgraded to a winter storm warning watch, to be followed by a warning, then a warning watch, then a watch, warning watch, then the warning itself, and then a warning, watch, and then a watch, and finally, all clear as the storm ends. Since the forecast may change, we've also issued a warning, watch, alert, update, watch, warning. The National Weather Service. So advanced, it's simple.
So obviously very funny, and we have a sense of humor in the Weather Service too. We thought that was extremely funny too, because we understand that there are a lot of misunderstandings about what a watch warning advisory is. And we also have a whole slew of various watch warning advisory products that we have that are certainly confusing. Sometimes we're confused ourselves on occasion. So what is the hazard simplification? It's really related to confusing terminology and a confusing range of products. This looks like the periodic table of the elements, all the naturally occurring elements out there, but I'll zoom into it in a second. But it is actually a list of all the various watch warning advisory products that we have out there. It's kind of crazy how many there are. And so the goal of this particular project is to simplify that, reduce the number of products, and really focus on the impacts rather than a label of some product. So as I mentioned, these are actually National Weather Service products before hazard simplification. We're years away from really making a big dent in this, but the winter weather products out here, we have simplified some of those already. So in theory, this chart will get smaller with time as we simplify the number of products and hopefully make it easier to understand. We used, so how do we do this, or how is hazard simplification working? It's using social science actually, and lots of focus groups, lots of case studies, interviewing people, asking people, what makes sense to you? If we used X example, would you make a wise decision versus Y example? So all those types of things using social scientists. It's also an institutionalized study. We're re-examining within the National Weather Service how these watch warning advisories are embedded in all the various policies. And then we're also reaching out to our stakeholders in emergency management and lots of public surveys. And we're getting ideas for improvement from them. We're getting ideas for new language and just the degree of change that our public and our stakeholders want. We're looking at all those things using social scientists. It's coming in 2 phases. We're still just in the first phase, and that's just repair. And I'll show you what we're doing to repair the really low-hanging fruit types of things with winter weather products and with flood products. Eventually, we want to get to the point where we can revamp the entire system. That's going to take a heck of a lot more work, a lot more coordination, a lot more study on how to best do that. And we are looking at other countries, because other countries have been pretty successful in changing or updating their system to almost like a DHS system where you're on various alert levels 1 through 5 associated with a color. We're looking at those types of things, but obviously any change is a long ways off from now. So to show you an example of what a new winter weather, and we've been doing in the Boulder office, we've been using this particular template for at least a year. Other offices maybe a year or 2, but still it's pretty new to most of you. The thing that's nice is that we simplified, and this was based on research, simplified the impact statement so that's a what, where, when, and then additional details. So trying to be short and to the point and providing the key information needed in the way that it's needed. So just kind of short and sweet, the what, where, and when. If you are curious about providing feedback on hazard simplification for the flood products and for winter products, that's the website. Henry's going to make this available afterwards too. So, I mean, you don't have to copy it down now, but just know that it's out there. Know that we love having your feedback. So I'm at the end of my presentation. So Henry.
Well, thank you very much. We appreciate you taking the time to do this today. And we're going to take questions. So if you have a question, and for Paul, we'll take the next, maybe if you can stick around for about half an hour, Paul, we'll see how many we get.
I can.
If you type those in, we'll be glad to get them. Also, for those of you who are listening to this broadcast, we want to apologize if you were unable to get on the webinar today. We had a little mix-up with our GoToWebinar folks and the capacity cutoff at 100 folks. So again, we hope you're able to watch this, and again, we apologize for any difficulties there. Okay, folks, anybody have any questions for us? We're looking for our first ones here. Nolan, are you on the call? He's not. Okay, so let's take some questions coming in. Here's one from Kath.
I was just muted.
Yeah, do you have any questions for Paul? We'll take yours as the first one off.
Snow, you described it well, but people still have the impression that the Weather Service does a bad job with snow forecasting. Do you feel like the new ways of communicating is helping reduce those negative feelings?
Yeah, thanks for your question, Nolan. I can definitely speak to the fact that the people making key decisions, whether it's keeping schools open or closed, and especially plows, road crews to keep the roads clear and the sidewalks clear, I'm reasonably confident in saying that these products have helped those decision makers immensely since we started working with them 2 years ago. And broadcast meteorologists, so the media loves those products too, because when they go on the air to talk about an upcoming snowfall, if there is a lot of uncertainty, maybe we're predicting 3 inches, but up to 10 inches could fall, they're able to communicate that in a good way with the general public. And so I know they appreciate those products. What I don't know, and what I'd be curious to know, I'm not sure how I could find this out, but is how well the public, if the public uses those products, and if so, has it been useful for them in making any local decisions, any personal decisions that they may have based on that information. Yeah, I think it's been really good for a small subset of the core partners that we regularly interact with.
That's good to hear. Very good.
Thanks, Nolan. Hey, we've got a bunch of questions coming in for you now, Paul. Here's the first one from Charles. He wants to know, are there any efforts for storm surge predictions? And we did have a webinar here, Charles, on storm surge. If you go back in our archives, that was earlier this year. But go ahead.
Yeah, and thanks for your question, Charles. That's an excellent question. And now that I think about it, I really should have hit the differences between Andrew, Katrina, and now with Michael especially, but all recent storms. The National Hurricane Center has a storm surge prediction unit, and they've been making huge strides in our ability to forecast storm surge. It's gotten so good that in the last couple of years, we are now able to issue storm surge warnings well ahead of time, not just for hurricanes, but also for extratropical cyclones, nor'easters. We can do storm surge warnings for those as well, because our ability to predict the surge has gotten so much better. They've also, and I can also say that they've improved their ability to display where the worst storm surge might be. And that's gotten better just over the last couple of years. In essence, they can kind of, using GIS technology, help show how deep the water could possibly be at your general location. There's still some room for improvement there in terms of the accuracy of the forecast and being able to show it with GIS capability, but they're working on it, and it's already doing a pretty good job of really getting it down to that local level of where the storm surge could be as bad as it is.
Thanks. Here's one from Bill, and he wants to know, how do you keep TV stations from maximizing the threat so to attract more viewers? Do you guys have any influence on that?
We don't have a whole lot of influence on that, but what I will say is that through developing really healthy relationships with them. I can speak to in the Denver market, we have a chat room where they can ask any question, we can ask them questions. It's a really good two-way communication. We've been starting and have had pre-season workshops with them. And so building that relationship has helped ensure that the information that we provide is the same information or similar information that the broadcast meteorologists provide. In other words, if we're saying one thing, the broadcast meteorologists are saying roughly the same thing. They're communicating it better, but they're not going off the rails and and saying something that probably isn't going to happen. We're all saying the same message, which is pretty key to enabling the right decisions. And that's the way it is in the Denver market. We're really fortunate to have fantastic, all channels, all broadcast meteorologists have been really good. And we want to keep that going just so that we're all on consistent message. Now, I know in other markets that may not be the case, but I think the way to fix that is to really develop those relationships way before an event happens and just try and get on the same page.
Thanks, Paul. Here's one from Tom in Boulder, and you may know this gentleman very, very well. His question is, any consideration for estimating snow density? 6 inches of fluffy snow won't bring down branches on tree leaves, but 6 inches of wet plastery snow will.
I figured I'd get a good question from my dad. Good question, Dad. What I would say to that is, as local forecasters, we do make an attempt and have forecast output that attempts to come at a snow density, because obviously that is a really big deal. And so what we try and do, let's say we're briefing CDOT, the Colorado Department of Transportation, and it's a really fluffy snow, and we know it's going to be a really fluffy snow. So some of the things we'll do is, even though it may show 10 inches of snow somewhere, we are able to provide additional information to them specifically that, hey, it's going to be really fluffy. It's just going to blow right off the road. It shouldn't be as big a deal as opposed to if it were really wet. So we do a pretty good job of doing that with our core partners. And in theory, we'd be talking to broadcast meteorologists as well about, yeah, it's going to be much more fluffy, so impacts wouldn't be as much. A lot of that gets lost in the translation of the products that we issue, because that's a really detailed thing. I will also say that we have access to, there's a numerical weather prediction model called the High Resolution Rapid Refresh. It's developed just down the hall. It's available nationwide, and they're doing some fantastic work on trying to estimate snow density in their model, which then will result in different varying snow depths that the model generates. So there's a lot more coming in terms of accuracy on snow density, and then the impacts based on that, just from what I know of that particular model. So I'm really excited about the work that they're doing on that, and hope that we can do an even better job estimating snow density and how that might impact things.
Great. So glad your dad could be on the broadcast with us today. Here's one from Judy Judy lives in Virginia, and she says hurricane and precip predictions seem very impressive. She lives in the Mid-Atlantic, but she says sometimes the forecasts are off, the daily ones, and she was wondering, a two-part question here. She heard there was a new weather model coming in line in January, so they won't be so relying on the European model. Can you talk a little bit about this?
I can, yeah, and I can say after living in the Mid-Atlantic for 5 years, that is gosh, terrain's hard to predict, but gosh, having a heat source like the Atlantic and then having terrain, that Mid-Atlantic's a very difficult place to forecast as well. So in terms of what's new forecast-wise coming in January, the Global Forecast System, GFS, is getting a major upgrade. And it's an upgrade to the way the core, the computer's core computes forecasts. The reason this is important is that with this new change to how the entire way that the model computer works, is that with this new change, we will have the ability in the future to get even higher resolution prediction out of this model. if we hadn't made this change, we'd be kind of stuck at the resolution that it's running at now, and with no real hope of improving the model. The way to improve a model is to have it a higher resolution so that it can predict and ingest higher resolution data, because most of the high impact weather that occurs on those really smaller time scales. So in January, that model is getting a major upgrade. Right now, it looks like it will be slightly more accurate than the previous model in terms of day-to-day weather, because we've been evaluating it for months, even up to a year. But I think when people will really start to take notice is once this is implemented, and the Weather Service now will have the ability to include much better improvements to the model in the future, because now because the way the computer runs now, it'll be able to implement much more improvements in accuracy for a whole host of different weather events. So I think in years to come, we're going to see the GFS model, the American model, make huge strides in improving the smaller scale impacts. So I'm really excited about it. You probably won't notice a whole lot different in January, but I'm thinking in the next several years, because of the change, it's going to get a lot better.
Thanks. Here's one from Dave in Tucson. Dave wants to know a couple of things here. How do you account for local geographic conditions, such as in Tucson, the mountains sometimes distort the forecasts? And he says, do various radars overlap so you do not have the blind spots caused by mountains? And I know we have a really similar situation down in southwest Colorado where there's really no radar coverage in some spots.
Yeah, thanks for the question. Yeah, that is a really big deal. It's a big deal. It's more of a big deal in the western U.S. just because radar coverage is tricky, because terrain can block the data. And in general, like the Grand Junction radar is up at 10,000 feet. So if you're looking at low-level data, for the deserts and the high deserts and the valleys that are over there, you're just not getting a whole lot because the radar data is so far off the ground there. But forecasters in the National Weather Service have been used to this issue since the beginning of time, essentially, where if we don't have a particular data set, say radar, or not great coverage with radar, we make up for it using other data sets as available. One thing that's really neat that we have access to now is the new satellite. It's a geostationary satellite, GOES 16. GOES 17 is almost operational. That'll be the Western U.S. satellite. And because of the resolution improvements in time and in space with that satellite, even if there isn't radar coverage, we're getting some indication of how severe a storm might be in those data sparse areas. We also rely on humans, like CoCoRaHS observers are fantastic in data sparse areas, but also just storm spotters in general in data sparse areas. So there are eyes and ears on the ground that's telling us, this much rainfall fell, or the storm looks like this. This is what we're seeing. And we look at their videos, the storm spotter videos. So we have a whole host of ways to overcome poor data coverage in those types of areas. I'll also add that, forecasters that have worked, National Weather Service forecasters that have worked in the Tucson office for a long time, that have worked in the Boulder office for a long time, we understand really hyper local scale weather patterns in our local areas. And so I believe we can and do add a lot of value where numerical weather prediction, where radars can't see, just simply because we chances are we've seen it before and we understand how it might evolve.
Thanks, Paul. Kathleen's been waiting a while with her question. She lives in Central Texas. She's very interested in understanding how and when thunderstorms are coming, how to understand when rain is expected. So I guess the question is asking, are there any resources out there, maybe by the Weather Service, on learning about the process where these happen? Maybe a local area says, these are the typical conditions that we might see for approaching thunderstorms.
Yeah, and thanks for that question. Central Texas is fortunate enough to have pretty good radar coverage. And so if it's severe weather and rain, that you are interested in knowing more about, especially as and when it might be coming to your area, my money is always on the radar data. So there are lots of, and I'm not going to name any apps out there, but there's lots of apps out there that have access to the full range of NOAA radar products that can alert you if storms are coming, that you can see for yourself if storms are coming because they're geolocated based on your cell phone. If you don't have a smartphone, there's websites where radar data are available that help show you when things might be coming your way. But my money, if that's your big concern, I would say radar would be a good place to start. And there's, like I said, there's lots of apps out there that can help you with that.
Thanks. Here's one from from Kathy, one of our actual former CoCoRaHS coordinators in New York State, and she was wondering, do you use more than NOAA weather radio warnings for hurricane notifications to freighters at sea? So how do you get those messages out to those boats out there, those ships out there?
That is a question I don't know the answer to. I know they have some satellite technology. Most big cruise ships and freighters will have satellite technology on and I'm pretty sure weather information can be passed through, but I don't know specifically how they get that information.
Actually, she's got a second part to that question, a little different, but wanted to know how difficult was it to coordinate with local emergency managers in FEMA when Maria was headed for Puerto Rico and Irma for the U.S. Virgin Islands?
I'd say from a meteorology perspective, it was pretty good because of the relationships that the local office in San Juan have built with the provincial emergency managers that are in that area, and with the relationship that the National Weather Service has with FEMA. So from a weather perspective, I think that went really well. I don't know the details about the response because I obviously don't work for FEMA and don't know any of those details at all, but from a meteorology perspective, I think it went really well. Our forecasts were pretty much spot on in terms of track and intensity following Maria for a week before it got to the island.
Okay, here's one from Michael. Michael wants to know, how centralized are the efforts to establish the communications and increase the understanding of local decision makers? So is it up to each weather service office to do what they wish, or is there a coordinated effort that comes out of DC?
It's well coordinated in terms of, how the standard level of communication, the tools we use to communicate that stuff, that's all pretty well standardized nationally. But we are flexible enough at the local level to work with our local partners on a case-by-case basis. Part of developing that relationship, which improves IDSS, is being able to understand, what does that partner need? Do they need us to communicate with them a certain way at a certain time? And we are flexible enough to modify how we do that with each partner on an as-needed basis. Because really, as I mentioned, our forecasts don't have any value unless the correct decisions are made, and that's all we want to see as a local forecast office. We want to make sure our customers are taken care of and that they make the right decisions. And so if they need something, we're going to do our best to meet that need, whatever it is.
Larry from Wichita Falls, you mentioned earlier about the new satellite, the GOES-17. Could you, I guess you didn't hear about when it was launched and when that'll be operational?
Yeah, so if you're in Wichita Falls, Texas, the satellite that will show the best picture of what's going on over Texas is currently operational right now, and that's GOES-16. There's several websites that show the data live. It updates every 5 minutes. Really fascinating, excellent data, high quality, high resolution. So yeah, that's been up and operational for it's over a year now. That one's been operational. The other satellite is moving into position now. In fact, it probably just reached its final location over the Pacific Ocean. That is GOES-17. But for Texas, the viewing angle from that satellite won't be as good. It's much better for California, Washington, Oregon, the West Coast, and Hawaii and Alaska. But Larry in Texas, I'd say check out GOES-16. It's been operational for a while. Fantastic data for your area.
Paul, is 16 or 17 best for us here in Colorado?
It's kind of funny, not in a ha-ha way, but just interesting funny, that once 17's in place, it's kind of a wash. Both satellites cover our area about the same. For eastern Colorado, 16's probably a little bit better. For far western Colorado, in that area, 17 will have the slightly better viewing angle. But either way, you can't go wrong. Both satellites kind of cover our area about the same.
Yeah, I've been watching 16, amazing detail and pictures out there, and maybe we'll put a link on our website to how you guys can look at that as well. Okay, here we go. We've still got a bunch. Are you okay to hang in there for a few more minutes, Wiz? Okay, we'll keep going on here, and again, if anybody has to leave, we are recording this. So William from New Mexico wants to know, does Albuquerque Weather Forecast Office, I guess, and other ones around the country have a Department of Transportation briefing page? So I guess the question is, do the individual offices around the country, the 121, have a briefing page for the local Department of Transportation?
Yeah, that's a good question, and there's no easy way to answer that, because that type of a thing would be, that decision to have that kind of page would be made on a local level. So I don't know for sure if Albuquerque does or not. You could always ask the office; they'll answer you. You know, we love answering the phone from the general public. We do have a page for our CDOT that's statewide, that's very useful. Even the public has access to it, but CDOT loves it. So I would be shocked if other states and other offices didn't have that type of thing, but I don't know for sure which office has it.
Okay, great. Here's one from David wants to know, how can private weather forecast services help the local community become a weather-ready nation? He says, obviously, private consults are for profit, but it's also possible to make a profit and help the community become ready.
Yeah, absolutely, and that's a fantastic question. The weather enterprise as a whole, you know, we're all charged with building a weather-ready nation, and the private sector is no exception there, and we rely heavily on their help. What I mean by that is there are so many things, so many needs out there for weather information that we just can't provide, for either based on resources, workload, or just the level of information that someone needs. There's businesses out there that need hourly updates on weather. I mean, we can't physically provide that type of support to a business every single hour, especially just a single business. But the private sector can, and they're fantastic at doing that. So yes, the private sector plays a huge role in building a weather-ready nation, and it's a role that we can't fulfill, that they do a really good job of filling.
Okay, we're going to try to answer a couple more, and we're going to stop taking questions at this time because we still have a few to get through here. Thomas wants to know, are there any improvements coming in the area of tornado or straight line winds to assist emergency managers, particularly utilities, with preparing for wind damage repair?
That's a very good question. I'd say there's efforts made in the future to improve that kind of thing, but as I'm sure most of you out there are aware, that is a very challenging forecast issue. Convection in general is hard to forecast, and then severe convection, especially straight line winds and tornadoes, that's a challenge. But what I can say is that I've seen a lot of improvements in the model I mentioned earlier, the high resolution rapid refresh. There are numerous efforts underway to improve modeling of these types of events, because right now we're constrained to detection or precursor signatures in radar, which doesn't give a whole lot of lead time. The future of increasing lead time and accuracy for these types of events, for me, in my opinion, is with prediction, numerical weather prediction. And there's a lot of efforts underway to address that very issue. But I'm sure we're going to be years away from really realizing those benefits. But they are out there.
Here's one from Brian. He lives in Southwest Michigan, and he is wondering, are lake effect snowfall amounts difficult to predict?
Yes. I don't know that they're harder to predict than really, complex terrain events, but yes, because of how small scale the systems are that produce heavy lake effect snow, they're always going to be a challenge. So yes, very difficult to do. As our that HRRR model and other models like the HRRR get better, we should start to see improvements in our ability to predict lake effect snow, because they require high resolution modeling. And so, yeah, I think those things will get better over time, but they are a big challenge.
Here's one from Tommy in Virginia. He wants to know, are there any plans of using quantum computing for weather models soon?
Thanks for the question, Tommy. I'm not even sure what quantum computing is. That's outside my area of expertise, but I know there are people in the National Weather Service that work on high performance computing, and I'm sure they know all about it and could probably answer their question. But yeah, I'm sorry, I don't know exactly what that is and how that might be used for the weather modeling.
Okay, here's James. Wants to know, what specific kinds of feedback are you looking for in the way of HAZSIMP?
I think there's two ways to provide feedback. One is just feedback on the stuff that's already been done, the stuff that's already out there, in terms of consolidating flood warnings, consolidating winter weather warnings and watches, and those types of things. So I know there's feedback on that, but I also believe there's an area to submit feedback on an idea you might have on, ways to totally change the system, whether that's a 5 color-coded system, a 1, 2, 3, 4, 5 with varying alert levels and those types of things. I believe there's an opportunity to provide something on that as well. So in other words, the quick wins, the stuff that we're doing now, and then the far out future, what might the design of the system, the warning system, what's that going to look like? I believe there's room for that as well.
So Ron just sent us a comment in about the ships, protecting the ships at sea. He says Navy meteorologist is called an orographer's mate, and most ships have one, and their primary mission is weather watching and predicting for ships at sea. So just a comment there by one of our viewers.
Very interesting, yeah.
Yeah. Okay, here we go. We got just a couple left. So Patricia wants to know, do you plan to initiate a cell phone alert process similar to the recent one sent by the president? I'm not sure what she's referring to. Maybe you know.
Yeah, no, and I know exactly what she's referring to. So that system is already in place, but why you might be wondering, what's going on, is that it's, to my knowledge, that it only alerts for tornado warnings and flash flood warnings. All the other various watches, warnings, advisories won't automatically be sent to your cell phone at this time, because we try and the plan with that is they're called wireless emergency alerts, and they're automatically sent to cell phones as long as you're in the area where the warning is. Try not to overload people with warnings and just trying to hit the ones that are truly life-threatening, like flash floods and tornadoes. However, there are tons of private sector, third-party applications out there that will alert you for any possible warning, watch, advisory that you could want in your area. All geolocated, geo-referenced, all that good stuff. You just have to find the right app that'll do that for you, but they're definitely out there.
I remember back in 2013 when we had the Colorado floods here, the reverse 911 calls coming in that night woke us up, and definitely helpful for many people. Okay, we got 3 questions left. We'll rattle them off here quickly. David wants to know, when did the Weather Service first use computers to predict weather? And you may not know that, Paul, but I'm sure it was probably sometime in the 60s or 70s.
Yeah, it was in the 60s. I don't know if it was the National Weather Service, but that was the first time that computers in general were used to predict the weather. And I bet it wasn't far behind in the National Weather Service, maybe the 70s. Yeah.
Okay, Benjamin writes, and he says, how do you implement innovations by the individual offices? I know the buff kit has been used much more nationwide, for example, to predict convergence zones near Seattle. How about innovations in messaging or other mesoscale modeling techniques?
Yeah, that's a fantastic question. I don't know if there's a real good answer in general on that, but I will say that, you know, a lot of the big improvements in the National Weather Service, some of those came from the local level. You know, if someone had a forecaster in a local office had an idea, you know, was to support a customer, and then that idea grew, and then other offices were using it. Then finally it grew upscale to the national level, where it was a national thing where every office used it. That happens occasionally at the local office. A lot of the times, though, there's a national initiative that gets passed down the chain to all the local offices, and so it can go both ways, really. Is there a really good mechanism for, you know, capturing all those local ideas? It definitely needs to be better, I will say, because there's so many smart people in the National Weather Service in the local offices that, you know, are solving partner needs in really neat, innovative ways. So yeah, I'm sure it can be better. It probably needs to be better, but there are ways of getting that done where a local idea just grows upscale into a national thing.
Okay, here is our final question of the day. It comes from Texas. Eldon wants to know, he says, obviously we have problems with drought here in Texas, as well as excess rain. As near-term forecasts are improving, are multi-month forecasts of rain also improving? So looking long-term at rainfall.
Definitely. The answer to that is definitely. One of a priority of the National Weather Service, you know, and this was from above them, from the White House level, they were interested in knowing more about seasonal and sub-seasonal forecasts of precipitation, you know, specifically for water management and in farmers and drought and those types of things. And they've definitely made strides in that area, with more to come. The Climate Prediction Center of the National Weather Service is the sole entity that does those official seasonal, sub-seasonal forecasts. Local offices, we just go out to day 7. We're looking beyond that for big events, but officially we only go out to day 7 in our forecast. But yeah, the Climate Prediction Center is the one that's really focusing on those sub-seasonal, you know, the 2, 3, 4 week forecasts, and the seasonal, which is monthly, and then 3 monthly forecasts. And they have all their products and improvements are on their page there.
Paul, thank you so much for answering all these questions. Hope we didn't wear you out with them today.
Can I ask one more?
Oh, what is your name, sir?
No, it's Nolan.
Oh, it's Nolan. Okay,
Nolan.
Yeah, we'll let Nolan ask one more. Go ahead.
Absolutely.
Since most of our CoCoRaHS observers who signed up for this call are still listening and watching, first of all, is that really a picture that you take out your office window, or is it just nearby? And secondly, what can CoCoRaHS observers do better to help the Weather Service?
Yeah, the first one's an easy one. That is literally a shot I took right outside my office window. It wasn't from today, it was from last year, but we had some low clouds that just kind of stuck around and made some pretty neat patterns after a light snowfall. So yeah, right outside my window. What can CoCoRaHS observers do better? Honestly, it's such a great program made up of amazing volunteers like everyone on this call. I mean, the only thing I can think of is get observers in areas that we don't have them yet. I mean, that's the one thing that and that's hard to do, obviously, but that's how it could possibly be improved. Because as I mentioned earlier, I was hoping to have some observers in some really data sparse areas of Grand and Jackson County, which is in our mountains just west of here and northwest of here, because there just weren't enough observations out there. But the observations we get, they're all high quality. They all come in at 7 a.m. all very useful. So I don't know that I can think of anything to improve other than just getting more observers out there.
Paul, what about reporting? What about reporting zeros? Do you guys appreciate that as well, to know where it hasn't rained?
At the local level, it's useful, but I would say, you know, nationally, especially for people that are ingesting the data into their models for, you know, water levels and those types of things, probably much more useful for them. At the local level, we don't use zeros as much, but I'm sure for the national folks, it's also critical. Well,
thank you for hanging in there and staying with us throughout the the broadcast today. Also for you folks on the watching the webinar, we really appreciate your being with us. So again, pleasure having you with us today, Paul. We'll talk to you again in the future. As we close our program out today, we want to tell our audience out there that please join us for our next CoCoRaHS Weather Talk webinar. That one will be on Thursday, January 17th, so in the new year. And Elizabeth Burkowski of the University of New Hampshire, she's going to talk about winter weather, climate, and snow. And she does a lot of work with the albedo of snow and so forth up in the New Hampshire area. So we really hope you'll join us for that. We look for an upcoming announcement on our website. And finally, folks, when you're signing off today, please take that brief survey that's going to pop up on your screen. We really appreciate that. So until next time, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and have a great afternoon.